Okay, so the goal of this session is to review WorkManager. Unfortunately, I didn't have the chance to prepare some good examples. Maybe we can build some small ones together. And then I want to introduce Google Maps, and that will be our last topic in this course. All right, so here it is. So the WorkManager, as we have seen last time, it allows us to schedule and execute deferrable background work. Deferrable means it is okay if I don't get the results immediately. It can be deferred to be done in the future, no problem. So if you are expecting a result immediately, then WorkManager is not the best option. So this is more for something that is it's okay to run in the future. But what is important here is the WorkManager gives you a guarantee that any work you ask WorkManager to do for you, it will be executed, even if the app exits and even if the whole device restarts. No problem, WorkManager will make sure your work will be executed. And the way it does that, whenever you ask it to do some work, it stores it in its own local SQLite database, and basically it goes ahead and executes it, either immediately or in the future. Now, when you schedule some work, you can also specify some constraints, which are some conditions that must be satisfied before the work should be executed. For example, if you are uploading some images in the background to cloud storage, you can ask WorkManager to only do so when the device is connected to Wi-Fi. And if something fails, you can also tell WorkManager how to retry. You can ask WorkManager to retry this job. For example, if you are trying to back up images on the device, and there is a network connectivity issues, or the server you are uploading to is busy and not responding, instead of declaring the work as failed, you can tell WorkManager, please retry at a later time. Hopefully this temporary problem, connectivity problem or server busy problem could disappear and the work will be successful. And I will explain this, how this can be achieved very easily using WorkManager. Now, as we've seen last time, for us to use WorkManager, we first need to add this dependency to our app. Then we follow these simple 4 steps. We create a class that extends worker, and then inside that class we implement the work we want to do inside do work, and that do work basically must return either success or failure or retry. And then once we define our work inside our worker class, we schedule this work and we ask the WorkManager either to do it immediately or to do it after certain delay or to do it periodically, as I will say here. So schedule the work either for immediate execution or for execute after some initial delay or execute periodically. Let's say after every 10 minutes, let's say after every 20 minutes or after every hour or after every 3 days. Depending on your app, you can decide the period at which the WorkManager will repeat this particular piece of work. So let's start with the first task, which is extending the work, extending the worker, implementing the do work and returning either success or failure or retry. So very simple. The piece of work you want the WorkManager to execute for you, you need to put it in a class, and that class must extend the worker class, and that worker class has one method which is do work, and you put your work inside this do work, and this do work must return a value of type result. Now, inside it, what you do, in case the app sends some input to the worker, then you can basically collect or read the input sent from the app to the worker using this input data object. So the worker class provides you this input data object, and you can basically read the input coming from the app. In here, I'm reading an input, an integer input named value, named count value. And basically, if this count value is not passed, because it is, let's say, optional, then I will use 0 as a default value. Now, don't let this const value confuse you. This is basically a string. So instead of putting here a string like this, count underscore value, this is basically the way you pass parameters and read them is by name. So every parameter has a name and a value, name and a value, name and a value. So instead of hard coding the name of the parameter, this is not very good. So instead, the best practice when you have some kind of string or some kind of value, you never hard code in your program. This is not very good. So what you do, you create let's say an object. Let's say you may call it constants, or call it whatever you want to call it, but constant is a good name. And then what you do is you say const val, and you give your string a name. Typically it is a uppercase, and if it's a compound word, you put underscore between the two words. In here, count value, and then you put your string in here, count underscore value. So, and then instead of using this hard-coded value, you use the constant. And basically you put here the constant, and then the compiler will say, I don't know what you're talking about. What is this const value? Tell, oh, don't worry, it is defined in this constant object. Yeah. So this way, in the app or elsewhere, you basically always refer to the same constant like this. But if you put it directly in here, you might make small mistake. Maybe in the worker you call it like this, in the app you called it maybe like this, and you have inconsistency, and you might introduce bugs in your program. So better to close this potential cause of bugs, and basically simply put these hard-coded strings, put them as constants, and then go ahead and keep using these constants whenever you need that particular string. So to summarize in here, what all I'm doing, I am reading what was passed to me from the app, and I'll show you how to pass inputs to the worker from the app. And by the way, the values that are passed always have a name associated with the value. So you can pass something, you have to give it a name, and then it has a value. So in here I'm reading from the input data object, I'm reading an integer, and the name of that integer is count value. And if that integer does not exist, then I will use 0 as the default value. Then I go ahead and do whatever I need to do. In here, I'm just doing a dummy loop that's looping and displaying this to the logcat. Then here is how you, optionally, if you wish to return something back to the app, you could do so. In here, I'm just getting the current date and time, and I'm creating a return an output data object. So I cannot just send this directly as part of the success. I can say result.success and I can pass some data like this. You cannot do just simply like this. You have to create a work data. So to do this, we have this nice extension function. I can just say work data of, I give it a constant and associate that constant with a value. And basically, this is how you take this and then you pass it as an output with the success method. If you have no output, you can just say return success, and that's it. The job has finished. Or if you have some data to pass back, you could do so in the output. You could do so, but you have to put it inside a work data object. It must be a work data object. Now, how do you create this work data object? By using this work data of name, associate that particular name. This is a constant, associate it with the value. And then you pass it back to the app. Now, if something goes wrong, you could either return failure, and this will basically the job will finish and the status of the job will be failed. Or you could return retry, which means you are instructing the worker to retry this piece of work. And I will explain this more shortly. So for now, let's just keep it simple. If something goes wrong, I've just set the status or the state of this work as failed. So I hope it's clear. So to create the piece of work that needs to be done, you put that work and you implement it in a class. That class must extend the worker class. Now, don't worry too much about this context and work parameters. These are used by the worker, by the work manager itself. So I have not seen any examples making any use of these. These are used by the system itself. So don't worry too much about them. Just all the workers, they have this, they take these two parameters, context and work parameters. But as far as you are concerned, you just focus on this do work, put your work inside this do work method. If you need to read something from the app, that was passed to you from the app, you use input data and you read it. If it's an integer, you use getInt. If it's a string, you use getString. Do whatever work you need to do. And then once you are finished, return result.success. If something goes wrong, return result.failure. And if you wish optionally to send some piece of data back to the app, you could compute that data you want to pass, but you still need to put it inside a work data object. And to create that work data object, you use this extension function work data of. You give it a name and associate that name with the value you want to return, and then take that output data object and pass it as a parameter to the success function. All right, now your worker is ready. You have implemented your worker, you have specified what this work is supposed to do, and you put everything in the do work method. Now, how do you ask WorkManager to go ahead and do this work on behalf of your app? So there are two scenarios. Either you want to do a one-time work request, which means you ask the WorkManager, do this work only one time, and that's it, do it and finish. So this is the simplest version. You go and say one-time work request builder, you pass to it the name of the worker class, and you'll say .build. So this will create for you a one-time work request, and then you take that work request and you go to the work manager, you get an instance of it, and then you say on queue, which means I am asking the work manager, please go ahead and execute this work on the background and execute it immediately. If you wish, you could also specify some initial delay. We'll say, I don't want you to execute it immediately. I want you to execute it after 10 minutes or after 5 minutes. Maybe you're doing this, um, you don't want to do this when the app starts. You might say, I want you to run this after 10 seconds. Let my app start peacefully without too much work going on. And then after 10 seconds, go ahead and do the work. Or I don't need it immediately. You take your time and do this piece of work after 10 minutes. So you could specify an initial delay. You could also, Allahu Akbar, you could also pass some input data to this work request. Again, how do you pass this input data? You create an object of type work data. And the way you create it, this is an easy way to do so. You use this extension function work data of, you give it a name and associate the name with the value. So it's a name value pair. So the input data is a name value pair, and you go ahead and pass it as a parameter to your one-time request, build your request, and then in-queue your request so the work manager will take care of executing it. So this is scenario one, where it is a one-time work request that you either execute immediately or after some initial delay. The other scenario is a periodic work request, where basically you want to run this request after every time interval. It could be minutes or hours or days. You could specify a period after which the work will be re-executed by the worker. So for example, you might have let's say the image gallery, and you want to back up those images, such as what Google is doing with their gallery app. So you could optionally configure it to back up your images in Google Drive. And basically, let's say the Google Drive will schedule this every hour. Let's say every hour the worker will wake up this work, compress the images, and push them to OneDrive, to Google Drive. And this is, as I mentioned before, the work manager has its own local database, and all these configurations that you specify here are stored in this work manager database. And the work manager is always running and watching the jobs that need to be run, and it goes ahead and executes them. So after you create a periodic work request using this periodic work request builder, you get an instance of the work request, and then you in-queue that work request. You in-queue it. Okay. The other thing you can do, you can specify some constraints, some conditions that must be satisfied before your work can start. And this you can see very powerful. You can say only do this work. You asking the work manager only do this work if the network is if there is a network connection, or if there is a Wi-Fi. You call it metered. Only if there is a Wi-Fi connection, or unmetered is for the Wi-Fi connection. Network type is unmetered, or metered for I want you to do this only when you have 4G or 5G. Or I want you to do this work whenever there is a connection, whatever the type might be. Whenever there is a connection, go ahead and do it. You can say only do this when the battery is not low. Only do this work when the phone is charging. But in here it doesn't matter. Do this work even if the device is not idle, even if the user is still using the device and the device is busy, still do this work. And here, even if the storage is low, I still want you to do the work. So you can, these conditions, you can configure them true or false, and then the work manager will make sure that this upload worker, for example, will not do its work until these conditions are satisfied. Once these conditions becomes true, the work manager will start executing the scheduled work. So you basically create a constraints using this constraints builder. You build them, you build your constraints, list of constraints, and then you set the constraints on your work request. It could be one-time work request or periodic work request, it doesn't matter. You set the constraints and then you build your request and you in-queue it, as we saw here. You get an instance of the work manager and you in-queue your request. So you always go ahead, create a work request, either a one-time or periodic. You configure it. You can pass some, let's say, some input data. You can put some constraints. And once you configure your work request, you go ahead and in-queue your work request, which means put it on a queue and work manager will take care of executing it. The other powerful feature of work manager, you can chain works. So instead of having one large worker doing so many things, you could break down the work into multiple workers and chain them together. And you can even do chaining with parallel and sequential execution. So in here, you can even define something like this. You might say start A and B, and then start A and C in parallel. Then once A finish, go and execute B. Once C is finished, go and execute D. And once B and D are finished, go ahead and execute E. So you can define something as sophisticated as this. So here is a small kind of example. In here, I begin with these two tasks in parallel, download and filter. I'll do this in parallel. So all I do, I put them as a list, and I'll say to the worker, please begin with these two tasks. Once they are done, move to this compressed task. Once it's finished, move to this upload task. And by the way, the output of this will be the input of the next task, and the output of this next task will be the input of the last task. So you can basically chain those workers, and the output of one worker becomes the input of the next one. And this basically makes your implementation more modular, much easier to understand, and much easier to maintain. And plus, you can do things in parallel. But if you put all your work in one worker, then that worker is too complex. You miss the opportunity of doing things in parallel. You miss the opportunity of taking advantage of this work chaining. So this is more recommended to break down your work into smaller workers, and then you can chain them the way it makes sense for your app. Not only this, you could also ask the work manager to retry your work if it fails. And your work will then be rescheduled according to a back-off delay and a back-off delay policy. So what I mean here, so for example in here, what you can say here, I'll say, I want you to do this upload request. I want you to do this upload request, but in case the job fails, maybe because, as I said before, maybe because the network connection is weak, or the network is down or busy, or maybe the server is not responding now, maybe it's too overwhelmed with other requests. So what I want to do in the job, in the worker, so in the upload worker, if something goes wrong, you don't send failure. You just say retry, for example. And then when when the work manager receives this result as retry, what it will do, it will use this back off criteria to decide when to retry. For example, here I'm saying please retry after 1000 seconds, retry after 1000 seconds, but I want you to first try after 1000 seconds, but keep increasing this retry period. 1000, then increase it to 2000, then increase it to 3000. This is a linear increase. Every time I want you to increase the delay with the hope that hopefully this temporary network problem or temporary problem hopefully will disappear, and then you will be able to run your job. An exponential here, uh, you could also specify exponential, where this, I'm not sure how it will behave, but the jump will be much more. Maybe it will multiply this by itself, maybe 1000 square. I'm not sure how the exponential will increase. But basically, this back off period will increase more rapidly using the exponential growth of this delay. Or you can put linear. I think linear, it goes, increments it more smoothly rather than doing big delays. But at the end of the day, you can see here the level of sophistication they have implemented in here. It's not only waiting for this particular period, but you try this period. If it doesn't work, extend the period. If it doesn't work, extend it even further. If it doesn't work, extend it even further until hopefully this work will successfully be done. And this will, of course, will be makes a lot of sense if it is due to temporary network problem or temporary server busy problem. This will work very nicely. And you can see here, without any efforts from your app, the work manager will take care of this. But for you to take advantage of this, your worker need to return result.retry instead of sending result.failure. If it sends result.failure, khalas, the work manager will not bother retrying that piece of work. Now what you can do here, there's another thing you can do is schedule a unique work. And I think this is quite important. In my opinion, this is very useful, especially for periodic work requests. So instead of just using this on queue, you better use on queue unique periodic work, and you give it a name. Now, just in case, so you see here, if I just do on queue, and if this one was run before, like let's say I put here, and I put on queue, and I schedule this to run every 6 hours. Then for some reason, my app runs again, and I run this work again, and I put 8. I will end up with two work requests scheduled, one every 6 hours and one every 8 hours. And this could be not very good. This might not be my intention. So it's better not to in-queue using the normal in-queue. It's better to use on-queue unique periodic work. You give it a name. And then this way, if that work request already exists, it will be replaced. So I think this is quite useful. Just keep it in mind. Instead of using on queue, you can use on queue unique periodic work, and you give it a name, you give it a unique name, and once you in queue this work, if it already exists, it will be replaced. Okay, the other thing you can do, and this is even more useful, if your do work need to do something asynchronously, such as a reading from a database, writing to a file, talking to a remote web server, So you better use coroutines for that, as we discussed before. So if you intend to call coroutines inside your do work method, so instead of using just a normal worker, you must use a coroutine worker. Then you can make this do work a suspend function, and you can run asynchronous task inside your do work. I think this is more practical than the usual worker, especially with coroutines being more and more used for many scenarios, as we've seen. So we have seen coroutines used with retrofit to interact with the remote web service. We already seen coroutines being used for reading and writing from a local SQL store using Room library. We already seen coroutines being used with uh, Firestore and cloud storage. So to take advantage of all these libraries and APIs from your worker, you better use a coroutine worker, and then you can make your do work a suspend function, and you can also specify and in which thread your work will be executed. So by default, it will execute in the default thread, which is optimized for computation, or you could switch to an IO thread if you are doing more like reading and writing from database, or reading and writing to a remote file server, or reading and writing and interacting with a remote web API. So you better run that work in the dispatcher IO, because these threads are optimized for network and disk IO operations. So in the lab, you will see this, and you will definitely use the coroutine worker to make your do work method interact with your database and with your Firestore. So to summarize, I mean, so far you have seen that you can chain work requests. You can chain work requests uh, and do them either one time or periodic. You can define constraints related to battery, related to storage, related to network. And once you configure and enqueue your work, it's guaranteed to be executed. You can also query the state of the work. You can say, how is the work going? Did it finish? Was it successful? Did it fail? You can query the state of your work. So how do you query the state of your work? So you can either basically let me see here. Yes, you can either do so one time. Here you are asking the work manager, how is my work having this particular ID? Did you finish it? What is the state? Is it running? Is it finished? Did it fail? You can just ask like this, get instance, and then you can ask the work manager. By the way, this is not the right way. Get instance always have, you need to pass the application context. Let me just keep it simple here. I assume I already have an instance of work manager. So I can ask for get work info by ID, or even more interesting, get work infos by tag. I think I didn't cover this, so let me just show you here. So when you, maybe let me show you here. I have an example of tag. Yes. When you create a work request, you can associate a tag with that request. A tag is a string. You could be like, this work request is to do with upload or sync or upload images. You can give it a tag, which is just a meaningful string associated with your work. And you can use that string when you want to cancel the job, or, by the way, this should be here. So you can use that tag to cancel the job, or you can also use the tag to check the progress of that request. Because the problem here with the request ID, you need to have a reference. To get this ID, you need to have a reference to the work. You need to have a reference to the work request itself. So what I mean here, let's say, okay, let me show you here concretely. Yes. So in here, we have this upload request. So I need to have a reference to this upload request, and then using this upload request that I have created earlier, I can go ahead and say, give me the status of my request. So I can say here, WorkManager dot get work info by ID, and then I'll say upload request dot ID. So I can do this way to get the state. I think this will return for me work info. I can say here val work info equals work info and then I can basically, let's say, let me just use simple print line, and I'll say debug here, and I will I prefer to put something like this so I can search for it easily, and then I can say here work info dot is done, is cancelled. What else can I get? I think is done, is cancelled. This is what I can get. Can I get something else? State. Work info dot state. I should be able to get state. Okay. Strange. Get. Anyway, looks like I only can get is done. Okay.
Can you try dot get and then dot state maybe? Because it said like it returns work.
Okay. Yes. Thank you very much. Okay. Thank you. Yes. A bit strange. Thank you. Yes, you're right. It's a bit strange API. I would prefer to just have workinfo.state. Yes, but that's the idea. Yes, very nice. So let us try this, by the way. So what I can do here, I didn't get a chance to really work on this. So let me just quickly do this one. So what I want to do, here is my upload request. So you can see here, it is simply getting this input, doing this loop, computing this current date and returning it. And if something goes wrong, it will retry. Okay. Now in my main app, what I want to do is I want to go to my work manager, and I want to go ahead and on queue this upload request. And if I just want to get a snapshot of the current, what is the current state of my work item or of my work request. By the way, the state, these are the possible states. Blocked is when, for example, if I am doing this type of multiple steps chained requests, so for example, if I am doing now filtering the images, the state of compress will be blocked, means it's waiting for other tasks to finish. Once all the previous tasks are finished, the task will go from blocked to unqueued, which means it is waiting to be executed. And once all the constraints are satisfied and the job is ready to execute and start executing, it will move to running. If everything goes okay, the worker will return success, result.success, and the state will change to succeeded. If something goes wrong and the worker returned the result.retry, it will go from running to in-queued. In-queued here, let's say I asked the WorkManager retry after 1000 seconds, then it will be in-queued for 1000 seconds. Once this 1000 second finish, it will move from in-queued to running. And if everything goes okay, it will move to succeed. If something goes wrong, it may move to fail. So during this whole lifetime, the app can always decide to cancel the whole thing, and then we move the work to cancel. So I can ask the work manager, what is the status of my particular request? And this will return me, if I say here workinfo.get.state, this will return me one of these string, either one of these states, either blocked, in-queued, or running, or succeeded, failed, or cancelled. So it will return one of these states. Now, if I want to continuously monitor this, and I want to, whenever the state changes, whenever the work item changes from one state to another, I can do so by, instead of just getting the info, I get info by ID as a live data. And as you already know, live data, I can observe it. I think this is not a very nice syntax, by the way. I think I can, maybe, let me see. Live data, let me just see here. Okay, didn't like it. No problem. Yep. Okay. So what I'm doing here, I'll say observe, and this is the owner, which is basically the current activity. And then I put a lambda expression here. And here I am observing the state. Whenever the state changes, I will get a worker info, and I will ask, please give me the current state, and display it in a text view in my case. Now, if the state happens to be the work has finished, I can read the output data. So I can go to the worker info and say, give me the output data. And then I can display this output data in a toast. So that's basically what's going on here. I can either get the current state and that's it, or I can even observe the current state. And I can do this either by using the work request ID, or even it's better to add a tag here. Let's say add tag. Tag is an arbitrary string. Better to put it as a constant. So I can put it here as a constant. Let me just rename this. I don't like this name. I think the best here is just to call it constants. And I can say here const val upload tag. And basically here upload underscore tag. So I give it basically a tag. So I'll go now back to my main activity. Here is my main activity. I basically, instead of, so I'll give this a tag, so I'll constant dot upload tag, and then in here, instead of getting these states by ID, I can get the states by tag. And basically what I can do here, I can go ahead and say um, constant dot upload tag. Now, because multiple jobs could have the same tag and I can track them together as a group, that's why I'm getting here a list instead of just one. Instead of just one info, I'm getting a list of info because this tag could be associated with multiple work items. So in here, let's just say, give me for the first item. It didn't like it. Maybe I put here 0. No, didn't like it. Okay, so what is this? This is a list. Expecting
I think get have one, more than one parameter. I think.
get. No,
No, no, maybe the list doctor try to dot get index.
sorry. Here get. You mean here? Uh, get
Yeah,
get.
there's no get index or something.
Okay, okay. Maybe this will work. Yeah, it's a bit not in.
I never expect this. So
Yeah, but anyway, like, it's fine. I mean, this is the way they have designed it. So basically, this will return me the list of worker info, and I'm getting the worker the state of the first job. And by the way, I can do the same here instead of by ID. Get worker info by ID. I can do it by tag. So for me, the advantage of using by tag, although it gives the inconvenience that this will become a list instead of one work item info, but I don't need this ID because this ID could be quite hard to get, especially for periodic work requests. How can I get this ID easily? So better to associate a tag with my work info, sorry, with my worker with my work item, and I can query the status by tag. So you have the choice, but I think by tag is it's more useful than by ID. So in here, I'm getting the state once off, just a snapshot, what is the current state? Or as I mentioned, I can observe the state change. And whenever the state changes, I get notified of the new state. I can display it and I can check if the state is finished. It's time for me to read the output data from the received the received work info. So the received work info, it has two important pieces of information: the state, the current state, and if it's finished, I also find in the work info the output that was returned from the from the worker. Remember, the worker can send, as you saw here, the worker can send the output values by creating a work data of associating a string with a value, and when you return success you can return back this output data. Now how do you read it? You read it from the work info. So from the work info you can either read the state, or you can also hopefully do dot output data, and then from here you can do get boolean, get byte, get double, whatever type you have passed. But in here you need to make sure the job is already finished. only do this Only do this when this is finished. Yes. is strange, is empty. No problem. So the state dot is finished. Yes, you go to state is finished. When it is finished, then this output, you will get something in the output. Otherwise, of course, the output will have nothing. The output data will have nothing. This will make sense to read it if the state is finished. Okay, I think it makes sense. Okay. Now the last thing I want to show you, in more sophisticated scenarios, especially if you have a long running task and you want your UI to get updates, not only is finished, you can even get percentage of progress. So if you are uploading, let's say compressing and uploading 1,000 images, so you will say every 100 image you will send, let's say 10% done, 20% done, 30, 90 until 100. So in your worker, you can do this. What you can do, you can send the percentage of progress by calling this method set progress, and you send back a work data specifying that the progress is 25%. And then we do some more work and you say the progress is 50%. You do some more work and you say progress is 70%, and so on. So you keep your app notified of the progress. And as you might guess already, the way you do that is the same get work info by ID or work info by tag, and you observe the state change. You keep observing the state change, and the worker info that you get back will have dot progress. Remember the work info, it has dot state. Now it also has dot progress, and then you can get that particular integer representing the progress. So you can observe the progress and you can display the level of progress in your UI. So this way, the background worker is communicating with your foreground app using this nice mechanism. As you can see here, very simple. The worker sets the progress and the app can read the progress by observing the get info live data. Now, if your app no longer needs that particular work, it can cancel it either by ID or by tag, either by ID or by tag, or it may decide to cancel everything by going to getting an instance of the WorkManager and then cancel all work. So all the work will be canceled. So you can see here, very simple programming model, a very powerful library. By the way, before this library was only introduced around 2017. So before this, doing this deferrable background task was much harder. Now with this API, it's much easier. And plus it works even for API, Android API, old API 14 to the current version of Android. It works even for older versions. And it makes life as developers much easier for us to be able to schedule and execute future work in the background. We have a guarantee that this work will be executed even if the device reboots. We can either have a one-time request or a periodic request that is done every period after, let's say, after 20 minutes or every hour or every day. You can put it as a periodic. If your app no longer needs that particular work, it can cancel it, and also it can observe the state of a particular piece of work. It can either observe the state as, let's say, it is in queued, running, succeed, or failed, or even in a more sophisticated scenario, if you have a long running task, that particular worker could report some progress percentage, and your app could observe the state change and could read those progress percentages and display them on the UI. So I hope you kind of excited to explore further this work manager. So in the lab, you will work on this. These are some more articles if you want to go deeper, and there is even a code lab, practical code lab that you can go through to practice what I explained here. All right, thank you very much. Any question? Any question on work manager? Okay.